Welcome to the Databricks GenAI Engineer Associate course on Stack Lessons. This is video 1 of 22. Over the next 21 lessons we'll work through every part of the Databricks GenAI stack: RAG over vector search, agents through the Mosaic AI agent framework, deployment with MLflow and model serving, governance through Unity Catalog, and observability with MLflow 3 and AI Gateway. Today is pure orientation. No technical content yet, just the map. Let's get into it. Most engineers building retrieval augmented generation today are stitching together 5 different vendors, one for the vector store, another for the gateway, a third for tracing, a fourth for governance, and yet another for the agent runtime. That fragmentation creates real operational pain. No single governance plane, multiple API paradigms to learn, and no unified place to see what your system is actually doing. Databricks owns all 5 of those jobs with first-party services, and that's the architectural bet this course is built around. By the end of this video, you'll have a clear map of the Databricks Generative AI Engineer stack, the 6 domains it breaks into, and the order to watch the next 21 videos in this course. No code yet, just the territory. Now that you've seen the stack on the map, let's pin down the 5 names you'll hear throughout this course. The Mosaic AI Agent Framework is Databricks' built-in platform for authoring, evaluating, and deploying agents. Mosaic AI Vector Search is the native vector index built on top of Delta tables. It's the retrieval substrate for retrieval augmented generation, or RAG. MLflow 3 is the observability and lifecycle layer, handling tracing, scoring, and prompt versioning. Unity AI Gateway is the central AI governance layer inside Unity Catalog. It routes, rate limits, and audits traffic to model endpoints, agents, and tool servers. And Unity Catalog itself is the single governance plane that ties everything together with consistent permissions, lineage, and audit. So what does a Databricks Generative AI Engineer actually build? Production RAG systems over real enterprise data, not weekend chatbot demos, but retrieval pipelines that have to be accurate, fresh, and auditable. On top of that, you build agents that reach into governed data and call real tools, like querying a warehouse or invoking a business function. The defining trait of this role is that everything is built on the platform's first-party services, end-to-end. You're not stitching together a vector database from one vendor, an orchestrator from another, and an observability tool from a third. You design, deploy, govern, and monitor on a single platform, and that's exactly what the exam tests you on. Here's how Databricks describes the role in the official exam guide. The certification assesses your ability to design and implement large language model-enabled solutions using Databricks, including breaking down complex problems and choosing the right models, tools, and approaches. Notice what's emphasized: design, decomposition, and choosing the right tool for the job. In production, that translates into concrete decisions, cost trade-offs between model sizes, query latency budgets for retrieval, governance boundaries between teams, and which tools an agent is actually allowed to call. Those are the decisions you'll be making on day 1. Here's the stack on one slide. Unity Catalog wraps everything, the dashed purple boundary on the outside. Inside that boundary, Vector Search handles retrieval, Agent Framework handles orchestration, MLflow 3 handles observability, AI Gateway sits in the traffic path, controlling who gets to call what. Databricks Apps hosts the front-ends and custom tools, model serving exposes the model endpoints themselves, and along the bottom, MCP servers, the model context protocol layer, give your agents access to tools in 3 flavors. Every later video in this course lands somewhere on this map. If you want a mental picture that sticks, imagine the stack as a city. Unity Catalog is the city government. It issues every permit and keeps every record. Vector Search is the public library where you go to look things up. Agent Framework is the courier service running between buildings. MLflow 3 is the inspector watching every delivery and writing reports. AI Gateway is customs at the city gates, deciding what traffic gets through, and Databricks apps are the storefronts where citizens actually walk in. Every service has a different job, but the city government touches all of them, which is exactly how Unity Catalog works in practice. Let's zoom in on a few of these services, starting with retrieval. Vector search is the retrieval substrate for RAG on Databricks. The key idea is that vector indexes sit directly on top of delta tables, so your embeddings stay synchronized with your governed enterprise data, no separate pipeline to keep in sync. This scales to billions of vectors at a fraction of the standard cost, which makes it the natural choice for large-scale enterprise retrieval. The way you get there is the storage-optimized endpoint tier, which decouples storage from compute so you don't need every vector hot in memory at all times. Next up, the agent framework, which is the spine that ties the other services together. It's how you author, evaluate, and deploy agents on Databricks, and it natively connects to vector search for retrieval, MLflow tracing for observability, Unity Catalog for governance, and MCP servers for tools. Sitting on top of that is Agentbricks, a task-first way to build agents. You describe the task you want to solve, and it generates synthetic data, builds benchmarks, and auto-optimizes across model choices for both quality and cost. Enterprise teams are already using Agentbricks to build research assistants and text-to-code agents on real enterprise data. MLflow 3 is the observability and lifecycle layer, and it has 4 pieces worth knowing by name. Tracing captures the inputs, intermediate steps, and outputs of every run, so you can see exactly what your agent did. Scorers run quality evaluations, either built-in metrics or custom large language model judges, and they can run on a schedule against production traffic, not just at development time. The prompt registry versions your prompts with automated optimization, so you can experiment without losing track of what worked. And logged models track application versions across the lifecycle. These 4 pieces span the full lifecycle of a generative AI application, from development through production monitoring, which is why they appear across so many different engineering scenarios. 3 services are easy to blur together, so let's separate them clearly. MLflow 3 is the recorder. It captures traces from every run, evaluates quality with scorers, and versions your prompts and models. It answers the question, what happened and how good was it? AI Gateway and Unity Catalog both sound like governance, but they do different jobs. AI Gateway routes, rate limits, and audits traffic to your endpoints and MCP servers. Think of it as air traffic control, deciding who flies which route. Unity Catalog handles permissions, lineage, and audit across every asset in your workspace. It's the rulebook everyone follows. Recorder, traffic control, rulebook, 3 different jobs, 3 different services. Here's a concrete scenario that surfaces the boundary between AI Gateway and Unity Catalog. Picture a finance team whose agent calls a third-party large language model and a tool server that reads from a governed delta table. Who decides the agent can read that table? Unity Catalog. It owns table-level permissions. Who enforces the rate limit on calls to the external model, captures the audit log of every prompt, and blocks the request if it exceeds the team's budget? That's AI Gateway. Both are part of Unity, but they govern different things. Catalog governs data and assets, Gateway governs traffic. When a scenario mentions central control, audit logs, rate limits, or policy enforcement on model or tool calls, Gateway is the answer. MCP servers come in 3 flavors, and the distinction shows up often. Managed MCP servers are the first-party ones: Vector Search, Genie, Databricks SQL, and Unity Catalog functions. You get them with 0 infrastructure to manage. Custom MCP servers are your own tools and your own code, deployed as Databricks apps and governed by Unity Catalog. External MCP servers are third-party services, proxied through AI Gateway for central policy and central audit. The choice depends on where the tool lives: built into the platform, built by you, or built elsewhere. The engineering surface area of a Databricks generative AI solution breaks into 6 domains, weighted by the effort you actually invest in production. Application development is the biggest at 30%. That's where RAG, agents, and MLflow 3 all live. Assembling and deploying is 22%, covering model serving, Databricks apps, and MCP design applications and data preparation are 14% each. Evaluation and monitoring is 12%, and governance, at 8%, is the smallest by weight, though Unity Catalog still touches every other domain. These same proportions are how the exam allocates its scenarios, so the time you spend on each domain in this course mirrors both. Building the RAG pipeline, wiring up the agent, and getting it deployed behind a governed endpoint is 52% of what a Databricks generative AI engineer does day to day. That's more than half of the real work, the design choices, the integration glue, the deployment topology. This course weights those topics in exactly the same proportion, so you spend the most time practicing where the stakes are highest. The exam happens to follow the same 52% split, which means preparing for the work and preparing for the certification are the same project. 2 quick mechanics before we look at the course structure. You'll see 45 scored items in 90 minutes, which gives you about 2 minutes each. Pacing matters, and the format mixes multiple choice with multiple response, meaning some items ask you to select more than one correct answer. Read every option before committing, even when the first one looks right. Logistics like cost, the proctoring vendor, and room setup are covered in the written study guide that goes with this course. Think of this course as a road trip across 22 videos. 17 of them are deep dive lessons. Each one takes a single topic, a single service, or a single decision rule and goes deep. 2 of them are checkpoints, where we stop and consolidate everything you just learned before moving on. 1 episode walks through end-to-end production patterns, so you see how the pieces fit together in a real system. 1 episode does worked examples, scenario walkthroughs in exam-style format, and the final video is a decision reference, the atlas you keep in the glove box for the week before exam day. Here's the recommended order, domain by domain. The heart of the course is application development at 30%. That's where you'll build RAG pipelines, agents, and wire up MLflow 3. But you can't start there cold, so we lead with design applications at 14%, how to scope a generative AI solution on the platform. Then data preparation, also 14%, covering delta tables, chunking, and getting embeddings into vector search. With that foundation in place, you're ready for assembling and deploying at 22%, model serving, Databricks apps, and MCP. Next, governance at 8%, Unity Catalog and AI Gateway in depth. And finally, evaluation and monitoring at 12%, scorers, tracing, and scheduled evaluation against production traffic. That's the path. Let's land it. The services on this map aren't interchangeable. Each one owns exactly one job. Vector search owns retrieval, Agent Framework owns the agent runtime, MLflow 3 owns tracing and evaluation, Unity Catalog owns data and asset governance, and AI Gateway owns traffic to endpoints and tool servers. Learn those job boundaries, and the scenario questions almost write themselves, because every scenario is really asking which boundary you're standing on. The 22 videos in this course are weighted to match where the real engineering lives, in the order the platform itself flows. Now let's see how much of this orientation stuck with a quick 5-question quiz. Alright, time to put your knowledge to the test. Question 1. Which 2 exam domains together account for the majority of the exam weight? Is it A, application development and assembling and deploying applications, B, design applications and data preparation, C, governance and evaluation and monitoring, or D, data preparation and application development? Take a moment to think about it. The answer is A. Application development at 30%, plus assembling and deploying at 22% comes to 52%, more than half the exam. That's also where most of the real production engineering work lives, which is why this course mirrors the same weighting. Question 2. A scenario calls for central rate limiting, audit logging, and policy enforcement on traffic to large language model endpoints and external MCP servers. Which Databricks service owns this responsibility? Is it A. Unity Catalog, B. AI Gateway, C. MLflow 3 Tracing, or D. Databricks Apps? Take a moment to think about it. The answer is B. AI Gateway. It's the enterprise control plane that sits in front of model endpoints and MCP servers, handling routing, rate limits, audit logs, and policy enforcement. Unity Catalog governs assets and permissions. MLflow handles observability of runs. Databricks Apps is a hosting layer for front ends and custom code. Question 3. A team builds a custom MCP server with proprietary business logic and wants to deploy it on Databricks under Unity Catalog governance. Which deployment target should they use? Is it A. Deploy it as a managed MCP server, B. Register it as a logged model in MLflow, C. Deploy it as a Databricks app, or D. Proxy it through AI Gateway as an external server? Take a moment to think about it. The answer is C. Deploy it as a Databricks app. Custom MCP servers run as Databricks apps, which makes them governable through Unity Catalog. Managed MCP servers are reserved for first-party services like vector search and Genie, and the external flavor is for third-party services that don't run on Databricks at all. Question 4. An engineer needs to capture the inputs, intermediate tool calls, and final outputs of every agent invocation, then evaluate response quality on a scheduled basis against production traffic. Which combination of MLflow 3 features supports this? Is it A. Prompt registry and logged models, B. AI Gateway and Unity Catalog, C. Tracing and scorers, or D. Vector search and agent framework? Take a moment to think about it. The answer is C. Tracing and scorers. Tracing captures the inputs, intermediate steps, and outputs from each run, while scorers evaluate quality using built-in or custom large language model judges, and they can run on a schedule against production traffic. Prompt registry and logged models handle versioning, not capture and evaluation. Question 5. What are the format and duration of the Databricks Certified Generative AI Engineer Associate Exam? Is it A. 60 multiple-choice only questions in 120 minutes, B. 45 multiple-choice only questions in 60 minutes, C. 30 multiple-response only questions in 90 minutes, or D. 45 multiple-choice and multiple-response questions in 90 minutes? Take a moment to think about it. The answer is D. 45 scored items in 90 minutes, which works out to roughly 2 minutes each. The format mixes multiple choice with multiple response, where more than one option can be correct, so read every option before committing, even when the first one looks right. That's your map. Every video from here on is tagged to a domain weight, so you always know how much each topic counts for. Subscribe so you don't miss the next 21 lessons, and I'll see you in prompt engineering.